Hello, abstract algebra students. We will now look at the well-defined property for double addition. And double addition is well-defined on the set of real numbers, which we will prove. Now, start by writing down what we want to show. And to figure this out, we apply the definition of well-defined to the set of real numbers and the operation double addition. And recall that double addition is the operation given by A star B equals 2 times the quantity A plus B. So we want to prove for all A, B, Y, Z in the set of real numbers if both A equals Y and B equals Z, then A star B equals Y star Z. Okay. So to prove this, because I have a quantified statement, I begin by letting the A, B, Y, Z, and R be given because I'm trying to prove a statement with a for all quantified. So let A, B, Y, Z in the set of reals be given. Now, I have an if-then statement. So I need to assume the if part and then try to prove the then part. So assume that both A equals Y and B equals Z. Now, I'm trying to prove that A star B equals Y star Z. And I don't see how to do this right away. So I'm going to go down to scrap paper. I'm going to try one common strategy in proving if-then statements is to work backwards from where you want to end up. So I want to end up with A star B equals Y star Z. I'm trying to think what that means. Well, I know that A star B is 2 times the quantity A plus B, and I know that Y star Z is 2 times the quantity Y plus Z. So I want to show those are equal. Now, I know that 2 equals 2. I know that A plus B equals Y plus Z. If I can get A plus B equals Y plus Z, I can just multiply both sides by 2. So let's see if we can try to get to A plus B equals Y plus Z. So this sort of gives me a sense of how I want this proof to proceed. I know that A equals Y and B equals Z. So since we know that all of A equals Y, B equals Z, and addition is well defined on R, it follows that A plus B equals Y plus Z. Okay, we've got this. Now, let's get 2 times the quantity A plus B equals 2 times the quantity Y plus Z. So we're multiplying both sides by 2, which is based on the fact that multiplication is well defined. So since we know that 2 equals 2, since we know that all of 2 equals 2, a plus b equals y plus z, and multiplication is well defined on R, it follows that 2 times the quantity a plus b equals 2 times the quantity y plus c. Okay, now that we have that, this is just the definition of double addition that says 2 times the quantity a plus b is a star b, and 2 times the quantity y plus z is y star z. Therefore, since we know that two times the quantity a plus b equals 2 times the quantity y plus z, by definition of double addition, we may conclude that a star b equals y star z. And that is the proof. Let a, b, y, z, and r be given. Assume that both a equals y and b equals z. Since we know that all of a equals y, b equals z, and addition is well defined on R, it follows that a plus b equals y plus z. Since we know that all of 2 equals 2, a plus b equals y plus z, and multiplication is well defined on R, it follows that 2 times the quantity a plus b equals 2 times the quantity y plus c. Therefore, since we know that 2 times the quantity a plus b equals 2 times the quantity y plus z, by definition of double addition, we may conclude that a star b equals y star z. Notice how with an if-then statement, you have to reason the if part into the then part. If you get stuck in the middle of an if-then statement, try reasoning backwards from where you want to show. Okay, more to follow.